Hey, Brooke, we're going to put together a short little video here on inequalities. This is the introduction to where we are. Up to this point, we've talked about expressions and equations, and inequalities are what we're going to do next. Remember that expressions have infinite numbers of answers because anytime we can find out what the variable's value is, we can get a different answer. Remember that equations has only one answer because when we put the variable in, it can only answer what it equals. And the difference with inequalities is it's kind of like a mix of both. Inequalities, you're going to have many answers, but not infinite numbers of answers. And we're going to start talking about that over the next couple of days. So here are our signs that we're going to be dealing with here. We have equality signs, such as equal and not equal. And then we have inequality signs with the greater than or less than symbols that we had before, and greater than or equal to or less than equal signs. All right, the line underneath it makes it so that it could be equal to it as well. So what are some real world examples of inequalities? Here's a couple, and you can pause this at any time and do your problem. But in this situation, if we were to think about what if you the height has to be at least 48 inches tall to ride the roller coaster, I've got to think about what inequality that might be. So we really want to think about what h could be, right? If you're at least 48 inches, okay, if you're at least 48 inches to ride that roller coaster, h has to be greater than 48 or at least 48. And so when we were choosing this one, hopefully you would choose the one in the bottom right hand, or the h is greater than or equal to 48 inches. Let's look at another one. Speed limit, right? When we're driving down the road, we want to ask ourselves, if the speed limit is 25, what can I drive and be okay without getting a ticket? So again, we're looking through out these different options. We want to make sure that S is 25 or less. So we're going to choose this one here in the bottom left-hand corner. S is less than or equal to 25 miles per hour, because if not, we'll get a ticket. Another example, all right? You must spend at least $30 to get free shipping, right? So I want free shipping. $29.99 is a penny less than 30. So can I spend $29.99 and get free shipping? No. So I can't do the equal to, right? But I could choose either less than or greater than. So if X represents my spending, I would use the greater than sign because I have to spend more than $29.99. So when we're talking about values such as this, inequalities can be solved the same ways we solve equations, right? We can solve it algebraically, okay? There are a couple different rules when we multiply and divide by negatives that we're going to talk about in a minute. So in this situation, x minus 2, to get x by itself, I'm going to add 2 to both sides, right? That means x has to be greater than 8, right? Because if I had 8 here, 8 minus 2 would be 6. 6 is not greater than 6. So I know that x has to be greater than 8 in order for this to be able to happen. Remember, we don't have to just deal with whole numbers. We have decimals and fractions that also work within that kind of confines. All right, let's go another one. Try this one algebraically. Pause this and then get ready to go. Okay, again, we're going to solve this algebraically. I'm going to subtract 5 on both sides. For my inequality to be true, x has to be less than or equal to 2, right? So because if I said 2 plus 5, that would be 7. 7 is not less than 7. So if it's less than 2, like 1.8 or 3/4 or something like that, that would all work. As an example. Okay, let's try another one. Okay, here we go. We got another inequality algebraically solved. So we're going to go in and get my ink up here. Divide both sides by 3. 9 is less than or equal to, x is equal to less than or greater than, or, let's say that again. All right, let's try that one more time. If I divide both sides by 3, x is greater than or equal to 9. All right, so if x is greater than or equal to 9, it could include 9, but it could include numbers like 10, 12, 13, 14.2, 18.5, things like that. Good job. All right, let's try one more. In this situation, This is a division problem. X divided by 2, well, the opposite of dividing by 2 is multiplying by 2. If I multiply by 2 on both sides, those cancel out. Multiply by 2 on this side. That gives me X is less than or equal to 22. All right, which would make sense, right? Because 22 divided by 2 is equal to 11, but I could choose another number such as 21, 20, 18 and a half, and so on. All right. So that got us through day one, all in one day. We're gonna, and then day two, I'd like you to try a couple of these problems on your own, and then I'll show you the answers momentarily. Okay, hopefully you had a chance to solve it. The first one would be X is greater than negative 11. Remember our rules, a negative divided by a positive is a negative. Over here, again, I'm gonna multiply by 4 on both sides. X is less than or equal to 32. And this is a two-step inequality, which is just like we do with equations. We're gonna add 2 on both sides. We have 3x is less than negative 18. Divide by 3 on both sides. X is equal to negative 6. All right, so the next thing we want to talk about is what happens when we're multiplying and dividing by negatives. That's the part that we got to at the end. What I'd like you to do is kind of fill out this chart. First thing I want you to do is I want you to just put the inequality sign in here that we see. So here we've got 2 is what to 10? Well, we know that 2 is less than 10. So then I'm going to have you go ahead and you're going to then multiply both sides by 4. Don't worry about that little c there. I'm not sure why that popped up there, right? So if I multiply this side by 4 and this side by 4, we can again say that 8 is greater than 40, all right? Now imagine if I divided it by a negative 2. 2 divided by negative 2 is negative 1. 10 divided by negative 2 is negative 5. Look what happens. When I divide by a negative, my inequality flips. Negative 1 is greater than negative 5 because it's moved to the opposite side of the number line. Okay, multiply these by negative 3. Negative 6. 10 times negative 3 is negative 30. Again, when I multiply by a negative, my inequality flips compared to the original problem. Okay, but if I subtract by a negative, my inequality does not change from the first problem up here. All right. So you're going to watch this video on your own. You can pull this up right off of Schoology. Kind of gives you that visual about a number line, and that's where you're going to stop today. Hit the at-home folder, get through as much of that stuff as possible, and hope you guys are having a great day. Thank you. Bye-bye.